Okay, so what we're going to do is we're going to look back at those three questions that were in that orange box. And what I did is I just took a little, or I basically just moved that orange box because in order for us to understand the vocabulary words in those three questions, we're going to want to reference our graph. So I wanted to make sure I had the box with the questions right next to the graph. Okay, so again, we were working with the equation y is equal to 2 times sine of x minus 1, and we graphed it right here. And what we're going to do is we're going to actually work with the that second question first. So it asks the question, what is the y displacement? And if you notice, with each one of those three questions, in parentheses, I wrote the definition of it. So that y displacement, it's a very basic definition, but we're going to call that the midline. And I want you to think, when you think of midline, I want you to look at our green curve here, and I want you to imagine taking this green curve and slicing it horizontally through the middle. So if we were to do that, we would slice it right through there. And that red line I just drew, I hope you can agree with me that that's where it looks like where we would perfectly slice this horizontally. And that right there is our midline. So that red line, it hits our y-axis at -1. So that means our y displacement is -1. Next, let's go ahead and move to the amplitude, and I'm going to try and color code this. So I'm going to move this in blue. The amplitude is the distance from that midline, so that's kind of why I wanted to do the midline first. Distance from the midline to the max or the minimum. So our red line, remember, is our midline. And let's find a maximum. So it looks like that right there. There we go. That's our maximum. And it's that vertical distance right there is our amplitude. So I'm just going to call it amp right there to abbreviate. So that distance is our amplitude. So that distance is from, remember, that is at -1 up to the top right there, and that is at +1. So from -1 up to +1, that is a distance of 2. So we are going to say our amplitude is 2. Now notice it says the definition, it says the distance from the midline to the max or to the min. It would still work for the min. So here's our minimum, and then we have our midline right there. Now that distance between them, so from that midline of -1 down to that maximum of -3, that's still a distance of 2. Now, so that's that. So distance of 2 right there. Okay? Next, I want to move to the period. So I'm going to do this, actually I'll do this in yellow. I think you guys can still see yellow. So the period is how long it takes to do one full rotation. So I want you to think of, we started right here at this yellow spot. And one full rotation would mean, okay, I would keep, whoops, I don't want it to be a straight line. I would be moving along. That right there is half a rotation. So you can kind of think of like we've done half the unit circle. And then if I continue, let's fill in that gap, there we go. If I continue right there, oh my goodness, I don't want that straight line right there. There we go. If I continue right there, I have done one full complete rotation. I'm kind of back at where I started at that midline. And we see that the yellow spot is blocking it, but that was at 2 pi. So that means our period is 2 pi. Now, I've had some scholars before, they kind of say to me, as they imagine, in this case it's yellow, but remember when we first graph our sine wave was green. I've had some scholars in the past, they say, oh, Miss Hamilton, I noticed that if I take that yellow or green curve and kind of connect the start and the end together, if I kind of connect them together, it would actually form a full complete circle. So I was like, yeah, sure, that's what a period is. It's how long it takes to do one full complete circle or rotation. Okay? Now, I want to go ahead and bring your attention back to our y displacement, so that midline, they mean the same thing, and our amplitude, because those values are actually hidden, well, not actually super hidden, in our equation. So, since we did that y displacement, the midline first, and remember we found that to be -1, and it's no coincidence that in our equation, right there, we have a -1. This value right here, that represents your y displacement. That is always your y displacement, or remember, that's also just called your midline. I've been calling it my midline, or midline for a while. So that number there is always going to be your y displacement. Now, very similarly, our amplitude, which we found our amplitude was in blue, it is no coincidence that that 2 right there corresponds with our amplitude. So that number that is being multiplied here to our sine, or sometimes it could be cosine, right? That is always your amplitude, okay? So if I were to give you any equation, I'm just going to make up one right now, totally on the spot. Let's say I make up the equation y is equal to 5 cosine x minus 3. We'll say that. So you would be able to say that just by looking at this and following kind of those rules that I was showing you, you would be able to say, here I'll color code this, that -3 would be your y displacement, and then this 5 would be your amplitude. Okay, so you can find those values by looking at the actual graph. That's kind of what we did first. Or you can look at just you can just simply look at the equation and know that that's where those values, or that's what the 5 in this case and that -3 represent. So that's something also to keep in mind.